Hello, everyone, and welcome to the next session of the live coffee talks presented by Azure for Technology Partners program, and which is designed to help our partners in migrating to Azure while providing uh, mm, free of charge business and technical assistance. It also provides validation funding and helps to market your software as a service and platform as a service offerings through Microsoft's commercial marketplaces. I would like to remind you that these sessions are held by Dom Daniel, and a lot of interesting coffee talk sessions await us. So to keep track of the upcoming events and not to miss the one you need, you can subscribe to our events on our social networks. And for this, you can follow our pages on LinkedIn, Facebook, YouTube, and Vimeo. You can also join the program by visiting atp.dom-daniel.com. And of course, if you have any questions during or after my presentation, feel free to leave them on the chat or comment section of the above mentioned platforms. My colleagues and I will try to answer them as soon as possible. Well, now let's move on to our topic. Today I will be talking about serverless orchestration using Azure Functions. And let's start with a simple example. Most of us have probably faced the case when we are standing in the line in the queue, and at the same time we would like to have a cup of coffee while standing in the line, and we can't leave our space because there are a lot of people. But imagine if we could do parallel or several tasks at the same time, like grab your coffee, get some fresh air, or at the same time don't lose your state. So the point of this here is that durable functions and Azure functions help us in our development problems or tests like parallel tests. And so durable functions can help us in solving complex workflow problems, more specifically in serverless architecture. Today, I plan to give you an introduction about what is cloud, what is serverless, and what are Azure functions, durable functions, and different patterns benefiting from durable functions, and of course, some demo. At first, I would like to show you the overview of cloud computing. So we see the big picture of cloud computing. We have the on-premises and the public cloud, where we have the different deployment models. We have infrastructure as a service, platform as a service. We also have function as a service and software as a service. Each of them, each deployment model is unique, and they are unique and different. And which one to use actually depends on the type of business requirements that you may have in your company or application. Today, I will be focusing on function as a service or serverless, in which we, as the developers, have the management or the assignment for the data and functions. Basically, Azure Functions is code-first approach. Much like other serverless providers, it allows your code to be executed in response to some event. And this is a simple code sample in C#, showing that I'm going to get HTTP trigger request to some endpoint. And whenever that request comes in, this little piece of code will be running. And the code you may want to run may be schedule-based. For example, I want to run some query every day on a fixed time. Or it might be message-based, like every time some message comes to a queue. Or it may be stream-based, like stream some data and process it constantly when it comes. With that said, let's first of all look through the term serverless. And Azure Function is a serverless technology. And serverless is all about the abstraction of servers. So when I publish the code which I have showed, I'm not worried about how to host, maintain, patch, and secure the servers behind the scenes. I just focus on the code. It is also event-driven. The resources to run the code are automatically provisioned on demand at whatever scale you are requesting for. And so you touch it to some type of event, examples of which I have already given. And you are only built for when your code is actually running. So if I have a serverless API and nobody calls it during the entire month, I will not be charged even a dime because And then if the next day, all of a sudden, I got thousands of requests, then I will be charged for those thousands of requests. Now let's go deeper into functions. A few key concepts to note when you are writing Azure Functions is that the core component is a function app. And an app is your unit of development. It is also your unit of deployment, and it is also the unit of scale. So a single app will be scaled as a unit. You can have multiple functions in your app, but your app is your primary unit of development, deployment, and scale. All the functions will have a trigger. This is the event source that the function is listening for and the data that will be pulled in. Every function can only have one trigger, and the service itself will automatically be listening to that source. So you are not charged. It is listening something like a queue waiting for a message to drop. And you are only charged when your function actually runs. The other piece, which is unique to Azure Functions, is a concept called bindings. Bindings are the data you can pull in or push out of your function without having to integrate with that service directly inside of code. For example, I want to build a serverless API with Azure Functions, so HTTP would be the trigger. But maybe I want to store data from that request, for example, in a database, in a NoSQL database like Cosmos DB. Now I don't want to have to write and manage my connection directly in the code. So I can use a binding to push data to Cosmos DB, and it will be done as part of my execution. And I can describe that integration through configuration. Maybe I actually want to pull in data from storage at the time of execution. I can use an input binding to tell the function that you are going to be triggered from HTTP, but also pulling data from, for example, Cosmos DB, from storage or whatever else, and at the time of execution. And to kind of sum up, we have triggers that start your event, and we have bindings which can allow you to flow your data in and out, and it is done independent of the triggers. These are the most applicable and useful Azure Function trigger types. Here is the HTTP request trigger, the timer trigger, queue trigger, Cosmos DB, and blob trigger. And here are the Azure Function supporting binding types. The first 5 or whatever else, and the timer, the blob storage are the most applicable ones again. Now, one of the nice things about Azure Functions is that you have a number of different choices on where and how you want to develop your functions. So you can develop entirely on the Azure portal, and there is a little code editor there where you can browser, and for locally, for working, use Azure Storage Emulator to check on the history and the logs of durable functions. Here are the top 5 scenarios where functions fit. And the first one is anytime you have an event stream that you might want to have some processing on. And this event can be an IoT event coming from IoT devices or machinery, but whatever it is, and something that is pushing a ton of data, diagnostic logs, because the nice part about function is that I can just write the code I want to execute and click publish, and now that piece of code will run for every single function that is happening, event that is happening. So it's kind of very easy to just attach this to the stream and have it scale automatically to do some processing on top of that stream. Web APIs and mobile backends are another very popular one. For example, if you want to send somebody something, and when you click that send button, you are actually kicking off some Azure function behind the scenes. And this is great because you don't have to worry about managing this API and scaling it. They just publish the function and it works. You will hear that serverless often considered to be as a glue between systems, and you might have a bunch of data that it is in some file system, and you want the data in a SQL database or in some file system. And being able to just simply write a function and tell it whenever new data get added, or every hour go pull the data and push it over to the system. It is something like a glue, to glue things together. If you're using pub/sub, queues, and topics and routing, functions are great actions on top of those pub/sub type patterns. And then for just general automation and scripting. Let's talk about some more advanced tips and best practices. These are some of the common hiccups that people do. One of the tips that you should hook your Azure functions to a monitoring solution like application insights, because this will give you the observability and insights of how your function is performing. Azure Functions will automatically add instances or servers as needed. Each of the instances will have the app to run on top of it, and every single of those instances may be executing multiple things in parallel. These are powerful servers, but they are just doing one request per server, so they are processing multiple requests in parallel per instance. So there is some parallelism even here on these instances. And now you can take advantage of the fact that there are servers powering serverless, and you can reuse certain resources across executions. For example, working with SQL client and HTTP client, you will only have to establish one connection and reuse it for subsequent executions. Okay, the other thing I would like to let you know is that with Azure Functions, you do have a lot of flexibility, and that you can run your functions in your ideal environment. So up to this point, I talked about consumption functions. These are functions that run in the serverless plan. You only pay for what you use. Resources are allocated on demand. So you can also run your Azure Functions in an up service plan. This plan allows you to reserve and have reserved capacity for your functions. So instead of spinning up on demand, you may need 20 instances, and you can manage them differently. That is, choose different hardware configurations. Maybe even have website or other processes running on top of it. You can also run in your own dedicated, isolated environments connected to things like VNets. You can run on premises with Azure Stack, and you can also use on premises. You can also use Azure Functions runtime. Here you can run on premises, and it doesn't require the full Azure Stack. And of course, you can run your Azure Functions on IoT devices. Now, I would like to talk about how you can orchestrate processes with functions. As I have mentioned, there is another way that you can process your functions and orchestrate data. And the other way that I want to spend the rest of the time of talking is about durable functions. And one of the important things is that to be aware of serverless and serverless plan is that a single function can only run for a maximum of 10 minutes, which means if you have a piece of data or some processing that may be running much longer than 10 minutes, that becomes very difficult to manage, and you would end up splitting up the task. And without something like durable functions or logic apps, you end up having to create queue and do everything yourself. Here with durable functions and logic apps, you can actually run things that last for a very long time, and it will manage the orchestration and state for you. So why it can't maintain the state? Here we have the client who is going to trigger a function. And that is we are just making a request to trigger a function. Then this trigger will automatically fetch the Azure functions and will load it to the container. Then the container will get executed. and give response back to the client. Here the state isn't maintained. When the container executes and gives the response back to the client, it dies. So the next time when the client makes a request, another container gets loaded and executed. So it doesn't maintain the state. If you want to maintain a state, you need to have an extra logic. Or, as I have mentioned, you can do it by Azure Durable Functions. So let's talk about Azure Durable Functions. It's an extension that you can pull into your app. It enables you to run this long-running and stateful serverless orchestration. This will manage the state, the checkpoints, queuing, all for you. And it is built on top of some open source library called Durable Task Framework, and which is just an open source framework to enable you to durably execute things. Here are a few common patterns that it solves for. The first one is the function chaining. For example, I have function 1. I want to call the function 2, then the function 3, and the function 4. Without durable, I would end up having to do something like this, where I would drop a message into a queue. It would have to pick it up from a queue and so forth. That's get really challenging to manage, to monitor, and to scale. But with durable functions, I can just write code to call function 1, function 2, and then function 3. Another popular one, this is what I'm going to show as a demo, is doing something like distributed fan-out, fan-in type of pattern, where maybe you get a bunch of data and you want to process it across a number of parallel executions. And you can describe this all again in code. Asynchronous response, where you want to return back a status endpoint and be able to poll until the long-running work is complete. Maybe you have some work that might take 5 minutes to execute, and you don't want to have to keep an HTTP request open for 5 minutes. Durable will provide out-of-the-box patterns for you to return back an immediate response, and then do the work in the background and let them check to find out when the work is done. Monitor, doing things like go watch this value for the next hour or the next day and tell if something changes. The next one is human interaction, and one of the samples with durable functions is doing like a text validation pattern, where you send somebody a code and you wait for them to put that code into like a website or text that code to a number. It might take, for example, 3 days before they finally read that text message and send back the text. But you could wait that long for that interaction. It's like an authentication thing. And the last one is aggregator. And in this pattern, the data being aggregated may come from multiple sources and maybe delivered in batches. The aggregator might need to take action on event data, and as it arrives, and external clients. And when it arrives, it maybe it would do some processing on that aggregated data. The tricky thing about trying to implement this pattern with normal stateless function is that concurrency control becomes a huge challenge. You can use durable entities to easily implement this pattern as a single function. Durable entities like eternal orchestrators are considered to be advanced scenarios of durable functions. Next, let's see how durable functions are running behind the scenes. What is actually happening? How are we able to run long-running processes but still have it be serverless? So here I have a very simple orchestration. This is in C#, and all I'm saying is create a new list and call the activity function and then that to that list. So what actually happens is my orchestration will start. It will run the first line of code, and so it creates a new list, and it's going to see this await keyword. And when it sees this await keyword, here comes the execution history. And the first thing it's going to do is going to look at the execution history to see, have it already done this action? And if it hasn't, the orchestrator will do this activity function. And it's going to call that function, and then orchestrator will go to sleep. It will scale to 0. The activity function gets triggered. It has been told that it has some work to do. It executes the work, and in this case, the response will be activity function something. That function is done. That function goes to sleep, and you will notice all of this has been stored in the execution history. Now, once the activity function is done, it wakes up the orchestrator. So now my orchestrator wakes back up. But here is the part that is important to understand. When that orchestrator wakes back up, it doesn't start from this line again, because it starts from the very beginning, because there is no way to just like resume a program from the very middle after you have scaled to 0. So the first thing it's going to do, it is going to create a new list. Now it's going to see this await keyword again, and it's going to look at the execution history. In this case, it's already done that action. So it will move on and do the next step. And then it's going to continue its next step and then return back the responses. So every time one of these functions is completed, the orchestration is going to replay. Now that's extremely important to know, because this impacts what your orchestration can do. It is very important to know that your orchestrator code must be deterministic. You cannot have values in your orchestration that will be different every time it runs. So you should design your workflow or orchestrator in a way that you get the same results all the time, because the whole orchestrator function will be replayed. And here is an example of deterministic versus non-deterministic functions. So in non-deterministic, you have lots of functions, but you don't know what they are doing, when they are triggered, and when they stop. But when you have a determined orchestrator, you have all the things in order through a workflow, regardless if you want your workflow to be running all the time or if you want it to be running forever, eternal. Because as I have mentioned, in durable functions, you can also create eternal orchestrations that can run forever. Now let's have some demo. I would like to show you as a demo fan-in, fan-out pattern, because it is one of the main usages of Azure Durable Functions. As we have already learned, fan-out, fan-in refers to the pattern of executing multiple functions in parallel and then waiting for all to finish. So we have to generate an invoice for a customer, which should include around 10 orders. So first we need to calculate the order amounts for each order, then generate a complete invoice. As we don't have enough time, I will show you the version which I have already implemented. So first of all, we have two activity functions for order calculation activity and order calculation and invoice generations. And two activities are called by the orchestrator. As there is around 10 orders, order calculation activity will be called for all orders parallelly. And when after all order calculation is completed, then the list of order amounts is sent to the invoice generations activity. So we have three types of durable functions. Starter, which calls the orchestrator function, the orchestrator, which calls the activity functions, and the activity functions doing the basic job. As everything is ready, let's deploy our function to Azure and test it. Here, Visual Studio has a built-in tool to easily publish to Azure. Here we choose where we are going to publish. And of course, we choose which Azure service we would like to host our application. Here we choose the subscription and the resource group or the resource type where we want to publish our code. But as you see, I haven't created yet Azure function or any resource group. So let's first of all go and create the function app. We can do it from here, but let's go to the Azure portal and do it from there. Here we click on create a resource, and from here we choose the function app. We must give details about the subscription. We also need to create a resource group. We would also need to give the function app name. And of course, choose where we want to host our code. As you see, here we have also the Docker containers, but I will just choose the code. Next, we choose the runtime stack, the version, and of course the region. Choose the region which is closer to you. I'm going to choose North Europe. And let's go to the next tab. The Durable Functions extension uses an Azure storage account behind the scenes in order to track the state of your orchestration. So we also need to create a storage account. We choose the operating system. Let's choose Windows. And of course, the plan where we would like to deploy. Let's choose consumption serverless. As I have already mentioned in my presentation, you should hook your Azure function into a monitoring solution. And here in Azure, it is application insights, because you can have the observability and insights of what and how your function is performing. So the next is the text. Let's skip it for now. And for now, let's pass the validation. And click create. So here we see that deployment is in progress. Let's wait a little bit more. So our deployment is completed. Now we can go to the resources. Here we see that we have a function app. Here our function app, which is our unit of development deployment. And for now we have no functions here. So our resources are ready. For now we can go to the Visual Studio and again try to deploy our code to Azure. So here we have already can see the resource. We choose the function which we have just created and click finish. Here we can see some information about function, and we can also configure here the application insights. So let's do it for now. Here we choose the subscription and the resource. And of course, here we have the application insight connection string, which we have to configure in the function app. So let's click next and finish. So we see that the configuration has completed. We can close it for now. And as we see, we are ready to publish. So we just click the publish and wait. So we see that the project has started to build. And here it started to publish. We see that our deployment has completed successfully. So let's go to Azure Portal and see what we have here. So here we see that our function app has already have it already have the functions which we have just deployed. And here is the small code editor about which I have just talked. So let's go to the overview pane of the function and copy this URL and see the result of our function. Here we see that in the JSON, this is JSON, and in JSON we get the ID of the orchestration, and here is it, and plus a bunch of URIs which can use to check on the status of the orchestrator. The first one is considered to, it is used to check the status of the orchestrator. So let's copy it. So here we see that the name of our orchestrator, instance ID of the orchestrator. We see that our orchestrator has already completed, and we have the 10 orders which we execute parallelly, and we see the output, which the invoice that is generated for the orders. And of course, you can also see this in the storage account. And let's go to the storage account. To the storage explorer. And as I have mentioned, Azure Functions, Durable Functions, keep the history and invocation logs of its invocation logs in two tables, where consequently are the instances and the history. Here we have that input, the same as we have seen here. And of course, the execution history here, where we can see that orchestrator started, here are our activities, and so on. So this was all for my presentation. I would like to thank you for your attention, and if you have any questions, you can leave them on the chat and I will try to answer them. And while we are waiting, I would like to remind you that to keep track of the upcoming events and not to miss the one you need, you can subscribe to to the updates of our social networks and follow us on LinkedIn, YouTube, Facebook, and Vimeo. So, well, it seems like there are no questions. Again, thank you for your time and attention.